Today's date is the 21st. All right, so this section's called Connecting Position, Velocity, Acceleration with Integrals. So what I want you guys to remember is we had S of t. That was position, right? If we took the derivative of this, the derivative of position is what? Is the velocity, right? So that was the derivative of position.
Can I borrow a pencil?
And then if I took the derivative of velocity, what did I get? Acceleration. So the second derivative of position is velocity, right? The second derivative of position gives me acceleration. The derivative of velocity gives me acceleration. You guys now have learned about integration. Integration, remember, is going backwards. So what I want you guys to think about is if I integrate acceleration, what does that give me? Velocity. Does that make sense? And then if I integrate velocity, that gives me position because I'm going backwards, okay? So we're gonna basically do what we did in the first semester now, but going forwards and backwards. So a particle moves along the x-axis with an acceleration function of 12t minus 4. The particle's velocity is 18 centimeters per second at time t equals 2. The initial position of the particle is 8 centimeters. What is a function x of t that represents the position of the particle? All right. This is a lot of what your homework will be for 8.2 is basically going forwards and backwards. So we're given acceleration, right? If I want to find position, do you guys agree that means I need to do an integral how many times? Twice, because I need to go backwards twice. So let's integrate this. So the velocity function is equal to the integral of the acceleration function. Okay? So it's going to be equal to the integral of 12t minus 4, and then it's because it's respect to t, dt. Is everybody cool with that so far? Talk to me. Yes? Okay, so if I do the antiderivative, remember, we're going to add 1 to the power, divide by the new power. What's 12 divided by 2? 6. So this is going to be 6t squared minus 4t. And then hopefully this wasn't you yesterday. Plus c. Don't forget your plus c. I'm not going to say names, but the test that was on top of the basket when I moved the test yesterday, the whole front page didn't put plus c. So if that was you, hopefully that wasn't you. Okay. Now listen. How many times are we doing this process? Twice. So I'm going to have a C and another C. Don't call them both C. So you can call this C, and then when you do the integral again, call the other constant D. I'm going to call this C1 for my first constant. Okay? Now, in order to do the integral again, I actually have to figure out what this constant is. So this is where the other information comes into play. It tells us that the particle's velocity is equal to 18 per second when t equals 2. So that means to solve for t, 18 is equal to when I plug in 2 for t. Does that make sense? So I'm going to highlight this. This is yellow. This is yellow. It's going to go there. So 6 times 2 squared minus 4 times 2 plus C1. You guys are AP Calculus students, so I'm assuming that you guys can solve this on your own. Okay, I'll just give you guys I'm going to flex on you guys a little bit. 24 minus 8 is 16. So subtract 16 from both sides. That means that C1 is equal to 2 if you solve it. Is that, you guys cool with that? So that means that my function, do you guys agree that that means that this number, where's my highlighter, is 2. So my velocity function is going to be 6t squared minus 4t plus 2. Okay, is everybody cool with that? Now to find the position, I have to integrate this. So x of t is the integral of velocity. So it's going to be the integral of 6t squared minus 4t plus 2 dt. Is everybody cool with that? Yeah. Add 1 to the power, divide by the new power. What's 6 divided by 3? 2. So this is going to be 2t cubed minus, add 1 to the power, divide by the new power. What's 4 divided by 2? So 2t squared plus 2t plus our second constant. All right, we love when the problems tell us this next part. Okay, so to solve for C2, they gave me some more information. It says the initial position. Hey guys, what does initial mean? 0. So what that means is, what am I going to plug in for t? Zeros. So if I plug in a 0 here, a 0 here, and a 0 here, it says that the particle is what? 8. So guess what that means? C2 is 8. Done. You don't have to solve that because if you guys should know by now, if you plug in a bunch of zeros, everything's going to go away, right? So that means that C2 is 8. Does that make sense? I'm recording this even though I'm not showing my work for that, so that way if you guys are lost on where that came from, you guys can come back and watch it. Like and subscribe. So that means my function x of t is going to be 2t cubed minus 2t squared plus 2t plus 8. All right, questions on that? Do you guys agree that we've done these problems, right, in chapter 6? It's just now it has to do with velocity and acceleration. You guys were given those conditions already. To find the constants. All right, this is a calculator problem. So the authors of these notes, they use their names all the time in these notes, so this is one of those problems. Mr. Bruce is driving down across town to Mr. Sullivan's house to play with a new set of Star Wars figures. Yikes. Mr. Bruce's speed would obviously vary throughout the drive, but because he is so cool, he came up with a function that represents his velocity at any time since he left his house during the 30-minute drive. Okay? Set up the expressions for the following scenarios and then solve, but use a calculator to solve. Okay. So this is the function that they give us. What does V stand for? Velocity. Okay? So velocity is in this problem, what is it? Miles per minute. Okay? So if it asks us to find how far, that's asking us to find how many miles. So what that wants us to do is, in order to figure that out, what do you guys think I'm going to do with this function? Take the integral. Because if I take the integral, that's going to give me miles. Because miles per minute is a rate. I just want the miles. Does that make sense? If I did the derivative going forward, do you guys agree that'd be miles per minute squared? That'd be acceleration. I want miles. So I want the position, so I need to go backwards. Does that make sense? So in order to write the steps for this, after 10 minutes. So do you guys agree that it starts at time t equals 0? And then it's going to go to 10. So this is going to be the integral from 0 to 10 of v of t dt. This is all the work you have to show. Because we're going to use a calculator. Okay? All right. So there's a wrong way to do this, and then there's a shortcut that I want you guys to use way to do this. Hopefully you guys agree that the shortcut's going to be better. Do you have a calculator? Do you have a calculator? No? Oops. So what I want you guys to do is in Y1, I want you guys to type in the function they gave me. That's your paper. So the sine of 0.3x plus the natural log of x plus 1 minus 2. Bless you. Now pay attention because we plug this function into Y1, right? So if we want to use this function over and over again, this is when you want to use this. Because does this problem only have one part? No, it has multiple parts. So this is why you want to do this, because the shortcut now is I'm going to go second quit and ask my calculator what's the integral, math 9, from 0 to 10 of, what do we type this into? Y1. So I'm going to go to my variables, go to Y variables, and click on Y1. And then hit DX, and I have my answer. And that's it. Make sure your calculator's in radians. If your calculator's in degrees, it's going to give you a whole different answer. So how many places do we round to in this class? 3. So it's approximately 3.01. We don't have to put the other 0. We're not in chemistry. 3.01. It's not asking us to justify or explain, so we can just tell them their answer. Now, this is why that shortcut's really nice. It says now, how far is he from his house after 15 minutes? So what's the only thing that's going to change about our equation? What'd you say? Change the 10 to a 15. Okay, so watch this. I hear some of you guys typing. Hopefully you guys are not doing what I think you're going to do. We could retype all this again, right? Or I could be smart. Scroll up, highlight it, hit enter, go into the top bound and change it to 15. And hit enter again. And there's our answer. These little tricks are so important, guys, to know how to do when you guys are doing your AP test. So he's about 3.397 miles. Bless you. If Mr. Bruce arrives at Mr. Sullivan's house after 30 minutes, how far away does he live? So what is that asking us to find? 0 to 30, right? Just change the top bound now to 30. Give an answer. 22. Can I see your copy? Because when you typed it in, you put too many parentheses. Just sine of that plus that plus that. So it's Did you guys get 22 point something? What is it, 22 point what? 824. All right. Now, this is an important kind of concept from this lesson. How many miles total did he drive? Okay, so do you guys agree that, how do I explain this? When you're driving somewhere, you have to drive on roads, obviously, right? It's not just like a direct shot. So you go, turn. So like your actual distance from point A to point B is not always going to be so straightforward, right? No pun intended. Straight, get it? Because you're actually turning and stuff. So what I want you guys to see is if this is the velocity, okay, do you guys see how there's some red area underneath the curve? There's some positive area. Okay. So if I wanted to figure out the total distance that he drove, what I could do is I could figure out like where all these cross the x-axis and add up all these areas, or I can just blank. Because what I really want is I want this area, but your calculator right now took into account that this area is negative. Your calculator took into account that this area is negative. So it did positive, minus. I want these to be positive. So how do I fix that? Absolute value. Okay, now what I want you guys to do is you look down here. This is what we want. Where is the absolute value bars? On the inside or the outside of the integral sign? Inside. So what you want to do is ask your calculator the integral from 0 to 30 of the absolute value of v of t. Absolute value goes around the function. Okay, so going back to my calculator. If you're taking your AP test and you forget where any functions are, we haven't done absolute value that often in here. So math 9, 0 to 30. Go to math, under number, ABS. Of y1 dx, and just doing some predictions, should our answer be bigger or smaller? Bigger, right? And there you go. 28.497 what? Miles. So what I was going to show you, and when these guys made their video, they did the same thing. If you ever forget anything, you can go to second catalog and you can search for stuff. So if you look at that, I think absolute value is like one of the first ones. So you can do a lot of cool functions in this calculator, but if you don't know where to find them, you can go to the catalog. So 28.497. So just make a note that this means total distance. Okay? So if you don't put absolute value, this just means from point A to point B, like if it's just like a straight shot. This means displacement. This means total distance. This is a really important idea that I need you guys to understand. Now, do you guys remember what this is? Without the integral, what does this mean? Speed. Good. And if you guys remember, I gave you the analogy, like if you floor your gas pedal and it's in reverse, do you go negative 15 miles per hour? No, you still go 15 miles per hour, but just backwards, and hopefully you don't hit something. Okay. Yeah, we're not going to finish by 10:55. Sorry, guys. All right. Problem number 3. A particle's velocity is given by v of t is equal to 4t cubed minus 6t squared plus 1. The function x of t represents the position of the particle along the x-axis. Find the position of the particle after 3 seconds if x of 0 is equal to 5. So read the question carefully. Is it asking us to find a function? No, it wants actual position. So we did questions like this in Unit 6, where this means that if I plug in 0 into the position, I get 5. I want to know what it is after 3 seconds. Does that make sense from 0 to 3? We want to know what the position is. So I have my velocity function. So this is going to be 5 plus the integral from 0 to 3. If I integrate the velocity, I get position. This hopefully looks familiar to problems that you guys did in Unit 6. Like if I told you guys f of 2 is 4, find f of 6. So you would do 4 plus the integral from 4 to 6, da-da-da-da. Okay? Again, you guys can integrate this by hand. The video that these guys did, they do this by hand. You guys have done a lot of integral practice the last couple weeks. So just to save us time, let's just plug this in our calculator. So make this your y1 now. 4x cubed minus 6x squared plus 1. You guys should get 35. This problem, they left out like what, 35 what? They don't tell us, so just go put 35. Part B, find the position of the particle after 2 seconds. If x of 1 is equal to negative 2. Anybody want to take a crack at it? What do I start the equation with? So negative 2 plus what? Integral from what? 1 to 2? Everyone's okay with the fact that you don't have to copy the equation in? Save yourself some writing and time on the AP tests. Don't write it out unless you have to do it by hand. If you're just putting your calculator, then just write V of t. Questions? Okay, number 4 is a problem that I wish they were giving you guys like a harder question in your notes because your homework has questions like this. However, what's nice about this problem right here is, do you guys see how they gave us a graph? There's problems like this on your homework, but they don't give you a graph. So this is really easy to do if you have a graph. If you don't have the graph and you're told no calculator, how do you solve this without it? So I'm going to show you guys how you do that. So it says, what is the total distance traveled by the particle during the first 4 seconds if the particle's velocity function is given by v of t is equal to negative 1.5 t plus 3? Show the setup and your work. So do you guys agree first 4 seconds is from time t equals 0 to time t equals 4, right? What did we do in a previous problem when it asked us to find total distance? What did we do with the function? We took the absolute value, okay? So what that means is we have a graph, right? Do you guys see how the area under the curve from here to here is positive? The area under the curve from here to here is negative. So do you guys agree that means I need to take the absolute value of this part? Does that make sense? So if you guys do the math, this is 3. This area right here is negative 3. But if I take the absolute value of this triangle, do you guys agree that this is actually positive 3? So if I added the total distances together, what's 3 plus 3? 6. So what I want to show you guys is how you can do this by hand without a graph. This is just a straight line, right? Math 1, good times, y equals mx plus b. This isn't that difficult. But if it becomes complicated, how do you figure out where you have to know like which part of the graph is negative? So do you guys agree that this right here is where the graph crosses the x-axis? So you need to know where the zeros are. And by knowing that, you can set this up, okay? So basically set your function equal to 0. So you subtract 3, divide by negative 1.5, and if you solve that, guys, you get 2. Okay, is 2 between 0 and 4? Absolutely. So that means that, I want to make sure we're okay. Is everyone cool with where this came from? Okay, where do we start the time that we're measuring? At time t equals 0, right? So what you would do is you would break this up like this. The total distance would be equal to, we start at 0. We know that it crosses the x-axis at 2. So the integral from 0 to 2. Now, if we don't have a graph, let's pretend like we don't know if this area is positive or negative. To be safe, if I take the absolute value of this number, does it change this answer? No. So I would just do the absolute value of everything so that way you know for sure it doesn't matter if it's positive or negative. The absolute value of the velocity plus, so 0 to 2 is our first chunk, from 2 to 4 is our second chunk. So from 2 to 4 of the absolute value of that velocity. Okay, so whatever this number is going to be where it breaks. Does that make sense? And you guys will know what I'm talking about when you guys see it on your assignment. And I know I sound like a broken record, but if you guys need help, don't be shy. Don't be shy, kids 559. Please come ask for help. Okay? Now what's crazy is we can do this by hand. I'm not going to right now just to save us time. But what's crazy, if you do this, guess what? You get 6. Which is the same thing from the picture. All right. Yeah, we didn't finish by 10:55. That's okay. AP problem time. I'm going to be honest, I think I'm only going to have time to do parts A through C before you guys leave because part D is long. So this is a... Can you wait? Sorry. This is a really, really, really common cut and paste FRQ question. What these people did, I'm pretty sure, is they just changed the equation and changed the situation, but everything else, the types of things they're asking you is pretty much similar, okay? So it says, Mr. Kelly and Mr. Sullivan are doing a morning speed walk race going down a straight street. For time between 0 and 20, Mr. Kelly's velocity is at time t is given by, so Kelly, K of t. That's why they call it that. is this equation. And Mr. Sullivan's velocity is given by Sullivan, S of t, 41 t cubed e to the negative 0.6 t. Both k of t and s of t are positive between 0 and 20 and are measured in yards per minute. So that's important, because they're velocities. And then time t is measured in minutes. This is going to be really important for later in the problem. Mr. Kelly has a 5-yard head start at t equals 0 and is ahead of Mr. Sullivan for the entire time. Okay. Now, if you guys are anything like me, when I was in college and high school, just looking at this seems really intimidating. Okay. Remember, what score do you guys really need to get a 3 on the exam? About what percentage? A 50. So between now and May, if we can get you guys really good at multiple choice, for all the FRQs, as long as you guys earn some points on every FRQ, you have a really good chance to pass. Do you have to get all 4 parts right? Do you have to? No. Does it help? Yeah. But part A is something that you guys should be able to do if you guys did the homework last night. So it says find the value of 1 over 5 times the integral from 10 to 15 of k of t dt. Using correct units, interpret the meaning of this. Okay, so number 1 in bold, what does this say we're going to use? A calculator. So all we have to do is plug k of t into y1 and calculate that. Should there be any reason why we get that wrong if we practice this enough? Hopefully not. So I'm going to do that with you guys. Can I see yours? I'm sorry. So alpha x stop it. 16,500 x squared minus 5x. Oh my goodness. Oh my goodness. What is it? Plus 74.33. Okay. All right. Don't forget the 1/5. So 1/5, math 9, the integral from 10 to 15 of y1 dx, and we get that. So remember, k of t was what? It's position, velocity, or acceleration? Velocity. And what do we do to velocity? We just took the integral. We took the antiderivative. So that means that it is now position. So if this was measured in yards per minute, when I integrate this, this means it's what? Yards. Good job. So that's 1 point just for being able to do that. This is 99.832 yards. Now here comes the tricky part. So using correct units, which we did, interpret the meaning in the context of this problem. Okay, when we did an integral in the last section, pay attention to the bounds. How far apart are these bounds? 5. What fraction on the outside? 1/5. So what does this mean about the problem? What do we do in the last section? You're finding what in the last section? This is not good, guys. What was the last section called? Average value. So what's the value in this context? K of t represents what? Velocity. So this is the average velocity. So Mr. Kelly's average velocity from time 10, t equals 10 to t equals 15 was this. Oh, not t equals 0, sorry. 10. Okay. When you guys do your AP test, remember it's everything. So part B, at time t equals 7, is Mr. Kelly speeding up or slowing down? Do you guys remember how we figured that out? Good job. Did you guys hear what she said? If velocity and what? Acceleration have the same sign, homeboy speeding up. If velocity and acceleration have different signs, slowing down. Okay, so make sure you guys understand this. K of t represents the velocity. So if I want to know at time t equals 7, the velocity, all we care about is the velocity at time t equals 7, positive or negative for this function. Okay? Now, didn't we already type this into y1? So this is how you're going to do this. To show your work, you're going to say k of 7. And right next to this, I'm going to say that this is the velocity because that's the k function. So k of 7. Remember, this is already y1. So all I have to do is go to my calculator and say variables, function, y1 of 7. And that's it. See how fast that is? That's why it's so important that we use that as like a tool for us. So we can write this down. 186.7, pretty much 8, right? If I round. 186.8. Which is positive, right? Obviously. Now, is there a shortcut I can do in my calculator to do a derivative? Oh, because you deleted y1. It's not there anymore. No one said anything. What's the shortcut? Math 8. Good job. So to know the acceleration, if this is velocity, do you guys agree that the derivative of velocity is acceleration, right? So k prime of 7 is going to be, so go to my calculator. I'm going to do math 8. So remember, we haven't done this in a long time. D over dx of our y1 at x equals what? 7. And we get this number, but more importantly, what do we notice about this answer? It is negative. So it's negative 19.033. 033? Okay. So what does that mean? What? Slowing down. Why? Because these are different signs, right? So Mr. Kelly is slowing down. At time t equals, what is it? 7. Since velocity and acceleration are different signs. Okay. All right, I'm going to pause here. All right, is the distance between Mr. Kelly and Mr. Sullivan at time t equals 7 increasing or decreasing? Give a reason for your answer. Okay, so if you guys read back to the beginning of the problem, it said that Mr. Kelly had a head start. So Mr. Kelly is always ahead of Mr. Sullivan, okay? So what you're really thinking about is K of 7 minus S of 7, is that positive or negative? That's what you're looking for. If it's positive, that means the distance is increasing. If it's negative, what that means is Mr. Sullivan is catching up because that distance is shortening because they're racing each other. Does that make sense? So which function did we type in to our calculator is K? Y1 or Y2? Y1. So what you have to do in your calculator right now is ask your calculator, go to second, quit. Ask your calculator for K of 7, go to your variables menu, Y1. Ask your calculator what is Y1 of 7. And it should give you that value. So in AP, we either round or they use the word truncate. I hate that word. Truncate to 3 places. But do you guys agree that's all we care about is it's basically 187? Okay, because 186.8. So K of 7 is approximately 186.8. S of 7, do something similar. Ask your calculator, what is Y2 of 7? You guys are AP students, so did we get that? Okay. Which number's bigger, K or S of 7? You got it wrong? I rounded wrong? Oh. What's 83? This? Oh, thanks. 83. Okay. Thanks. Okay, let me ask again. Which one's bigger, K of 7 or S of 7? S of 7. So if I subtract K minus S, you don't even need a calculator for that, guys. If you subtract that, is it positive or negative? That's all you care about. It's negative. So K of 7 minus S of 7 is negative. So therefore, the distance between Mr. Kelly and Mr. Sullivan is what? Decreasing. And that's your justification. Does that make sense, guys? That distance is getting smaller because it's negative. Okay. Part D, we had to wait till today to do it because it's kind of long. But you guys are going to learn something right now I've been so excited to teach you guys because I learned it at my AP training, something you guys can do. All right. What is the maximum distance between Mr. Kelly and Mr. Sullivan over the time interval 0 to 20? Okay, so my students, whenever it tells you to find a max or a min, and also an interval, what I want you guys to think about is, you guys remember when we found absolute max, absolute min, and we make a table? This is what it's asking you guys to do. Okay? So, the equation that we're going to use is, we have to read the problem carefully. So, I'm not saying you guys can't do it. On an AP test, though, to get full credit for this problem, you'd have to get all the parts correct, right? Like even myself, like something like this, when I saw the answer key, I'm like, oh, that makes sense. But like I would have probably messed this up too, but I'm going to try to explain this to you guys the best I can. Mr. Kelly has a 5-yard head start, right? So at time t equals 0, it's going to be 5. So the equation we're going to use is 5 plus. He's accumulating because he's walking. Which function is Mr. Kelly, K or S? K. So it's going to be the integral from 0 to x of k of t dt plus, oh sorry, not plus, it's minus, because the distance between them is decreasing because we're assuming Mr. Sullivan's catching up to him. So minus the integral from 0 to x of s of t dt. Is everybody cool with that? It's minus because the distance between them is shortening. 5 plus because he had a 5-yard head start at the beginning. Is everyone cool with that idea? Okay, so in order to find the maximum of something, so pretend like this is like our f of x. What did we do back in Unit 5, Chapter 4, in order to find the max? What would you do to the equation? Take the derivative. So you need to take the derivative of this, and you're probably thinking, whoa, what the heck? But there's actually something nice about this. If I take the derivative of this, what's the derivative of 5? 0. When I take the derivative of the integral, what happens to the integral? It cancels. So all I have to do is take the x and plug it into there. So it's just going to be k of x minus s of x. Is everybody cool with that? Now, if I want to find the max or min, we want to know when this equals what? 0. Now I'm going to show you guys a shortcut. If I want when this equals 0, do you guys agree I could add s of x to both sides? How do I know when two functions equal 0 on my calculator? When they intersect. Don't we already have these in our calculator? Okay, so let's go back to our calculator. Tangent, what the heck? Real quick, make sure these are bolded now. So hit enter. Hit enter, graph. Wait a second. Why is it not showing up? Okay. All right, I lied. We're not going to do it that way then. Let's leave it like this. My bad. Erase this. You could do it that way, but if I want to know when this equals 0, that's when it crosses the x-axis. So do you guys agree that this was y1 and this is y2? So what I'm going to do is I'm going to let y3 be y1 minus y2. So I'm going to go back to my calculator and define y3 as y1 minus y2. Like that. And then I am going to go back up and get rid of this and get rid of this. One thing the problem also tells you is what's t trapped between 0 and what? 20. So is everybody okay with this idea? Once I have that, I'm going to go to my window and change the window to 0 to 20. And then hit graph. Okay. Remember how I told you guys there's something cool I'm going to teach you guys right now? This is the cool part. You guys ready? Everyone paying attention? I'm recording this in case you guys need to see this again. Okay. Do you guys think these are going to be perfect numbers? So this is when, if you need to save a horrible number, this is where you're going to do it on your calculator. Okay. So how do I find the 0? Do you guys agree I go to second trace? 0. Okay. Do you guys agree that this tick mark right here is 3? and this tick mark looks like it's 5. So do you guys agree that this 0 is between 3 and 5? So for left bound, I could do 3. Right bound, I could do 5. And then that's a shortcut you guys can use too to get that 0 and hit enter. And it looks like it's 3.9268073. Let me check my notes, make sure that's correct. Yeah, it is. Did we get that number, guys? Okay. Now, do you guys remember? Now, pay attention, guys. When we found our zeros, do you guys remember to find the absolute min and max? We would do a table, right? And we would plug our zeros as part of those numbers in that table. So do you guys agree this number is really important that I use this number, right? So I want to save this number, but I'm going to be using my calculator, so I don't want to write this number down. So this is what you're going to do. Second quit. Your calculator is very smart. So don't type anything in yet because that answer, that 0 you just found is your answer. So what you're going to do is there's a button down here that says store. Click on store. And it should say answer to. What it's going to store that answer as is anything that you call it. So what we're going to do is we're going to call that number A. Because whenever we use that A button now, that's going to retrieve that number back. So I'm going to do alpha A and then hit enter. Because then that tells my calculator whenever I tell you to do A, it's going to pull that number up. So then I don't have to write anything down. This is really important because in Unit 8, you're going to be finding when graphs cross, and you're going to be using this feature all the time. So if you guys need help with that, raise your hand. Did you find the 0? Yeah. So second quit, and then store alpha A. Oh, I'm sorry. Yes. So I want you guys to do the same thing for the second 0. And what do you guys think I want you guys to store that as? B. So go to the graph, second trace, 0. What number is that? 1, 2, 3, 4, 5, 6, 7. So 7 to 10. So this is what you guys should get for the second 0. So second, as soon as you get that answer, second quit, store alpha B. Okay, cool. Hopefully you guys think that's cool. I didn't know that was even, I knew that button was there. I never knew what that button was for until I went to my AP calculus training and we're doing those problems that we're going to do here in a couple weeks. And the guy that was leading it was like, oh, just store the value. I'm like, what are you talking about? And he showed me, I was like, that's so cool. So this is a really cool feature. Okay, so on our actual example from the calculator, X is approximately 3.926. And then X was approximately, what was it, 8.926? 2,4 what? So we stored that as A, stored that as B. So we're gonna make a table now. So X, Y. So remember, guys, when we do a absolute max or absolute minimum, remember your endpoints go in your table. So 0, this number, I'm not going to put A, I'm going to put 3.926, dot, 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 8.9, or 8.247, dot, 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 and then 20. All right. Now, everyone good? It's okay. It's okay though because our calculator knows it's A and B. Okay. Now, to find the y's, don't do this. What do I plug these into? The red? No. The black. Do I have this in my calculator yet? But can't I type this into my calculator? I could call the black what? Y4. Okay? So this is how you're gonna do it. Do you guys agree that this value right here is Y1? This value right here is Y2. So in Y4, I'm gonna type 5 plus math 9, the integral from 0 to x of Y1 dx minus 0 to x of Y2 dx. So 5 plus math 9 from 0 to x of y1 dx minus math 9. Whoa, what is happening?
Can we do just integral of y1 minus y2?
No, because, technically I think you can, but I don't want to do that because if it's wrong, then I have to retype it in. Okay. It's usually like 4 and you get an hour. So it's like 15 minutes per FRQ. So this is why I'm kind of being like hard on you guys. Like, please make sure you guys have your calculators out because I want you guys to practice doing this because by the time May comes, hopefully you guys are so fluent with your calculator, you guys can type this really fast. Okay? I know we're almost to March already. Okay. Does everyone understand why we're plugging it into here? Because this is like our original f of x. Okay? So if I want to do my table now, this was y4, right? So if I want to fill out my table now, all I have to do is ask my calculator what is y4 of 0. And guess what? It's 0. I think. Hold on, let me check. I don't want to be wrong. Oh, I lied. It's 5. Which makes sense because when you plug in 0 to 0, remember when you have an integral with the same bounds, isn't it just 0? So 5 plus 0 minus 0 is just 5. Okay, how am I going to do the next part? What am I going to ask my calculator? Y4 of what? Of A. Ask your calculator what is Y4 of A because your calculator knows that A is this crazy number. So functions, y4 of alpha A. And you should get that. Whoa. You guys didn't get that? Oh, you know why? Look what I typed at the end. Let's try it again. Is that better? Yeah. So 533.048. Okay, just to save us time, if you do, this is B, right? This is A. If you plug in that number, you should get 428.790. And if you plug in 20, you get 959.666. Yikes. So which is the largest Y value? What? 959? So then to answer this question, remember you're trying to find the maximum distance. So the maximum distance between Kelly and Sullivan is 959 0.666 yards.